to get this one. It says the path of a ball being bounced down a hill can be described by the function, this function right here. That's a messy one. Okay, so and it's defined within this domain right here, and it says on this function, x is the distance down the hill in feet, and y is the height of the ball in feet. It says what is the distance between the two bounces? Well, let's get the graph of this thing. So let's shrink this up a little bit, and need to move over some so I can see what I'm doing. So here we go. Let's put in the coefficients. So my a is 3, my b is 2. See, it has a quadratic term. Then a minus 3 is my c. Then a minus 1 is my d. My e is the number in front of the x outside the absolute value, which is minus 1. And my constant is a negative 0.5. Wow, that has everything in it. Now, if we take a look at this graph, let's look at it from negative 1 to 2. Okay, so down here, we'll change the viewing window from negative 1 to 2 because that was the domain of this problem given. And this is the path of this bouncing ball. Bounces and bounces. So here's the two bounces. And now we need to find the distance between these two bounces. Well, it turns out that you can find these vertex points by doing what? Well, by setting this quantity that's underneath the that's inside the absolute value symbols, set that quantity equal to 0 and solve it. Well, that is actually a quadratic equation. So to help us solve this, we could use the quadratic sheet. And here's my coefficients, 2, negative 3, and negative 1. So let's do that. Let's go to the quadratic sheet and put in my coefficients. Let me zoom this up so you can see it. And those coefficients were 2, negative 3, and I believe negative 1. 2, negative 3, and negative 1. Yep. Negative 3 and negative 1. And right here, these are not the x-intercepts on the actual problem, but this tells you the location where this thing actually bounces at 1.7 and at negative 0.28. So if you want to find the distance between these two bounces, you would subtract them. So let's take a look at that on our absolute value graph here. So one's over here at negative point something, and the other one's over here. And then we would just subtract these two distances, and we already know what those two distances are. So there's the graph, and we get these two values and then just subtract them, and we get the distance between the 2 points to be 2.06. If you take this number and subtract off this negative number, that's the same as adding them together. Now, that's the distance, the horizontal distance from this point to this point, like if I was going directly straight across. But actually, that distance, I'd have to use the Pythagorean theorem to get that distance because it's a angled distance, you see, like that. So to get the actual distance, we'd need to get the y coordinate and use the distance formula, also known as the, we could use the Pythagorean theorem or the distance formula to do it. And that's going to be shown later on in this section. But that's where they actually bounce right there. All right. So if you understand what I'm doing here, I think you're a super genius. Yeah, especially on this last one.